Okay, practice problem number 3. You might have read it already. I've got it started here for us. Let me go ahead and read it again. It says the results of a study on body temperatures of men and women are shown in the table. The data are from random samples from normally distributed populations. If you didn't know, average body temperature varies from person to person. Some people run a little bit hotter, some people run a little bit cooler. And so the question here is, so you see that information, we're looking at men versus women, and we've got all that data there. We know the sample averages, we know population standard deviations, and we know sample sizes for both groups. And then finally it says using a 0.10 significance level, test the claim that men have a different body temperature than women. Hey, maybe men and women on average are statistically different. You might sometimes you hear it called have a now I'm blanking. They have a statistical significance to their body temperatures. Okay. In my experience, men are typically warmer than ladies. Maybe you, but hey, we got to base our findings on the data, not experience. All right, so step 1. Let's get into it. The null and alternative hypotheses. When you have a the two groups, when you have not even just two independent groups, if you have hypothesis testing with two samples, this is always your null hypothesis. The difference between the two is 0. We assume that the average man and the average woman have the same temperature. Okay. What can change is the alternative hypothesis. Now, it's always going to start with mu1 minus mu2. It's always going to have 0. The only thing that might change is, do we have a less than, a greater than, or a not equal? To understand what this is going to be, we got to read the question. Don't base it on the data in the samples. Get it from the question itself. So it says, test the claim that men have a different body temperature than women. Different simply means not equal, right? Now the data might tempt you to write, an inequality, but this is what the statement says. They're just not equal. They have a different body temperature. Okay. Now, you may remember from chapter 9, if you have a not equal, that alters how you think of the significance level. So I did this sketch. They told us to use alpha equals 0.10. So with the not equal, we have to put some of it up at the top and some of it down at the bottom, half here and half here. Also, you might note that right there at the center is 0, because we're thinking the difference between them. And if we start straying away from 0 one way or the other, will we end up landing in the shaded region, whichever way it might start to tip? Okay. So step 2, the most important step. The test statistic I don't want to show you just yet. As you look at that data, well, they tell us it's sigma, right? That's the giveaway here. They tell us the population standard deviation. So we know we're going to use the z-score, and I just went ahead and filled everything in. Also, they already told us how to pick group 1 and group 2. The men is already labeled as X1. They are group 1. The women are labeled as X2, so they are group 2. So we don't even have to decide that. We'll take the average men minus the average woman. Now what's cool, this is always going to be 0 in a 2-sample test, because that's the difference between them, mu1 minus mu2. We assume it to be 0. Then they give us the sigmas, right? 0.84, So it's 0.84 squared over that sample size for the men, 45, and plus 0.65 squared, the sigma for the women, over sample size 59. Fairly big difference there in sample sizes, but that's not a problem. Big sample sizes too, 45 and 59. They're doing our due diligence here to get some very reliable data. Okay, so if you go ahead and compute that whole thing, you should get 0.73 when you round it. So definitely practice that. You want to get the same values that I'm getting. Obviously, you'll be doing that in homework too, but I would encourage you, even in lecture, check my calculations. Okay, so there's our test statistic. Step number 3, it's the p-value. So probability that capital Z and 0.73, we like the Z, we're going to use the normal calculator in StatCrunch. But what do we put here? We had a does not equal back in our alternative hypothesis. So now we got to make sure we decide. We can't put a not equal there. We need a greater than or a less than. There's a couple of ways to make sense of it. Turns out, in this case, group 1 had a higher average than group 2, right? The men had a higher sample mean than the women did, right? Like hardly anything, but they were a little bit bigger. Because, right there are the numbers right there. Because that was a little bit bigger, this came out to a positive answer. So you could even base it on the fact that that's a positive number, that it's got to be a greater than. Or you might base it on, what I was just saying, that the average for the men, the average for group 1 was bigger than the average for group 2. So there was the greater than. Okay. All right, well, putting that into our StatCrunch calculator, I went ahead and just rounded to 4 decimal places since we didn't have a bunch of zeros like last time. I like 4 decimal places if I can keep it that way. Sometimes there's just too many zeros there at the beginning. All right, so we got the p-value. Now we will compare the p-value to the significance level, but we got to be careful here, of course, because we divided that significance level in half because of the does not equal. Although I don't think that would change the answer. The p-value is the bigger one, easily. Well, if the p-value is bigger, do we reject the null hypothesis or do we fail to reject? You might know by now, we fail to reject. That is not nearly enough evidence to reject the null hypothesis. It is some evidence. The men definitely had a larger average than the women, but it was not enough to get us down under 5%. We're way up at over 23%. So far from it. We fail to reject. If you wanted that stated, the interpretation, here it is. There is not enough evidence that men and women have different body temperatures. That's the way I decided to phrase it. You might word that a little differently. Okay. So while we are discussing this problem, turns out practice number 4 really builds on this same example. So I want to go ahead and do that. You might not have read the part about the confidence interval for 2 independent groups. So you may want to pause the video here, go and look at what it says for the confidence interval of 2 independent groups, and then we'll do number 4 together. Okay, so here we go. confidence intervals for the two groups. So now things really seem overwhelming. We've got these three styles that we have to identify, and now these new formulas, and matched pairs, independent groups, 2 samples, 1 sample, on top of just the 3 different versions. I'm really presenting the confidence intervals for the 2 sample groups for your sake when it comes to your final project. Okay. In your final project, you're going to be doing hypothesis testing, confidence intervals, and that sort of thing. So it might be that you pick 2 independent groups or 2 or matched pairs or something. Well, then you're going to need to know how to do the confidence intervals for those along with the hypothesis tests. So it's primarily for that. I believe there is a homework question for independent groups, 1 homework question for a confidence interval and independent groups, 1 for a matched pairs, and 1 for the proportion based. But that's not something I'm going to test you on. You're not going to be tested on confidence intervals of the 2 sample groups, only the original confidence intervals that we did back in Chapter 8. But for our practice sake, if it comes up for you, obviously in the homework, but even more so on your final project, let's go ahead and look at the confidence interval for that same problem we just did with the men and women and their body temperatures. So you see those formulas there. Obviously, we're going to use those. So number 4 says, from the data on men and women's body temperatures, find the 95% confidence interval for the claim that men have a higher body temperature than women. And we'll round to 2 decimal places. Okay. So, of course, the 2 pieces of information you need for confidence interval are the point estimate and the margin of error. So we have these new, more complicated formulas, but they have the similar traits as our new test statistic formulas. The point estimate for independent groups we find with x bar 1 minus x bar 2. Well, for us, we can just take our numbers from that table, x bar 1 minus x bar 2. That's what our numerator was back in the test statistic anyway. Turned out it was 0.11. Okay. Of course, the more difficult number to calculate is the margin of error. Well, we still have just those spots for sigma 1, sigma 2, n1, n2. That all looks the same. That was the denominator. But of course, we also have that z-score that goes in front of it. But we're going to find that z-score the same way we did back in Chapter 8. What would it be here? Oh, looks like I continue on the next page. We look at the confidence level. So they're asking for the 95% confidence interval. Well, 95%, and we're looking for a z-score, we know that's 1.96. If it was a different number, or maybe we didn't remember that, use your StatCrunch calculator backwards, the way we did it in Chapter 8, and you'll produce that number. Okay, so we've got everything. Put that z-score in, put all of these numbers back in, big square root, right, all that. You should get 0.30, and that is me rounding to 2 decimal places. So that's what the problem asked for. Okay. And to finish it off, well, we take our point estimate, subtract margin of error, point estimate, add margin of error. Here it is right there. There's our 95% confidence interval. Negative 0.19, comma 0.41. So what does that even mean? I didn't give an interpretation, but we are 95% confident that the difference between the average man and the average woman's body temperature will fall somewhere in there. So the differences in average body temperature very, very small. It goes a little bit on the positive side since our data had men a little bit higher. But we're also allowing it to go pretty fairly negative too. So maybe there's a good chance that actually the average woman has a higher body temperature than the average man, or I should say men on average, women on average, although we go a little bit higher on the men's side. Okay, that will do it for this video. I'll see you in the next one.